In this video, I want to talk about the idea of formal charge and see how it can help us predict when some atoms won't follow the octet rule or where to put some electrons that we just aren't really sure what to do with. So I've already done this example ClF3 as showing how it hybridizes using the energy level diagram. So let's see, instead of using that method, how we can see what ClF3 is going to do for my Lewis structure. ClF F, F. I'm not drawing this in the perfect shape. I'm just putting those in. And now I'm going to octet everybody. And then I'm going to count my electrons. So 7 for the chlorine plus 3 times 7 for the fluorines for a total of 28. So if I count these electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. What I can see is I have 2 electrons left over, or I need 2 more electrons. How can I decide where those 2 electrons are going to go? Well, that's when I'm going to use formal charge. To do formal charge, what you do is you consider the effective nuclear charge, or whatever the unshielded nuclear charge is, and then you consider all the electrons that are associated with the atom, and you consider the overall charge. For electrons in a shared bond, this is not like an oxidation number. You give each atom credit for one of those 2 electrons. And then obviously the atom gets credit for all of its lone electron pairs. So all these guys, Cl and F, are all halogens, so they all have an effective nuclear charge of 7. So let's look at the fluorine's formal charge. It has 7 in the middle, and then 1, 2, 3, 4, 5, 6, and then it gets one of those 2 from the shared bond for 7, so it has a formal charge of 0 just right now. So when we are doing this for formal charge, the rule is we want to get the lowest formal charge possible. So 0 is perfect. So for these extra 2 electrons, I really don't want to put them on the fluorine. But let's consider the chlorine so we can see if they fit there easily. Again, I would have a positive 7 charge around my chlorine. And then 1, 2, 3, 4, 5 electrons, as is. So my formal charge right now would be plus 2. But if I add 2 electrons in the form of a unbonded pair, I can take that formal charge down 2 more and go all the way to 0. So formal charge tells me to put those extra electrons on the chlorine. So now chlorine isn't following the octet rule, but it is at a formal charge of 0, and so that's something that we want, meaning that that's where those 2 electrons will go in this Lewis structure. Now, that's a little bit confusing because now we have 10 electrons around it, but remember from an energy level diagram, because chlorine is large enough to have D shells, it can actually form even more than 4 bonds. It can form 5 bonds if it needs to, because it has the ability to hybridize with an hybridization like an sp3d, which creates 5 electron sites. Another example here, and this is a very strange one, nitrogen dioxide. So we throw nitrogen in the middle, throw oxygen on either side, and then we'll just octet everybody. Now we'll consider our electrons. So nitrogen has 5 electrons, and both of those oxygens have 6 electrons. So we can see right away that something strange is going to happen because we have 17 electrons, an odd number, which we do not see very often. So how many do we have here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm way above. So the first thing I'm going to do is I'm going to form a double bond. Now that was an arbitrary choice. I could have put it over on the other side, but I just happened to put it on the right. But now I'm down to 18 electrons. I've got to take away 1 more electron. I have to go to 17. So who should I take it away from? Well, let's do the formal charge of these guys. This oxygen would have an effective nuclear charge of plus 6. 1, 2, 3, 4, 5, and 6 electrons associated with it. So its formal charge is already 0. So unless we absolutely have to, we're probably not going to take the electron away from that guy. Nitrogen has an effective nuclear charge of 5. 1, 2, 3, 4, 5 electrons associated with it for a formal charge of 0. So again, unless we have to, we're not going to take the electron away from that guy. This oxygen has plus 6. 1, 2, 3, 4, 5, 6, 7 electrons. So its formal charge is -1. So that's the guy we want to change. So what we'll do is we'll just take away one of his electrons. Now he has plus 6 and minus 6 for a formal charge of 0, which gets all the formal charges as low as possible. Remember, when I say the lowest possible value, negatives are, I understand, are lower than regular numbers, but what we mean is the closest to 0. So -1 isn't as good as 0. So that's what nitrogen dioxide would look like, which is kind of a strange atom because it has that single electron. Like that. So a formal charge is just another tool that we're going to use when comparing options for Lewis structures to figure out how an atom will actually bond.